Voyager 1, NASA's farthest traveling spacecraft, continues its remarkable journey through space, beautifully transmitting valuable data from the deepest regions of the cosmos. For nearly 5 decades, this extraordinary space probe has revolutionized our understanding of outer space. However, recently the spacecraft has been transmitting alarming data back to Earth, leaving the entire space industry in shock. Are these unsettling data the result of a technical malfunction or the activities of extraterrestrials? Join us as we uncover the truth behind these shocking transmissions. Since the dawn of time, scientists have been captivated by the mysteries that lie beyond our celestial borders. This curiosity led to the groundbreaking launch of the Voyager 1 and Voyager 2 spacecraft, among other remarkable space missions. These groundbreaking missions, which have been discussed for decades, began with the launch of Voyager 2 from NASA's Kennedy Space Center on August 21, 1977. 2 weeks later, on September 5 of the same year, Voyager 1 followed suit. These twin probes, each weighing a substantial 720 kilograms equivalent to a small car, were propelled into space during a unique alignment of the outer planets. Throughout their incredible odyssey, these intrepid explorers navigated diverse trajectories in speeds leading to a pivotal moment on December 15, 1977, when Voyager 1 surpassed its identical twin due to variations in their path. Since then, Voyager 1 has become an invaluable resource, providing us with an abundance of knowledge and unraveling space-related mysteries. Before we dive into Voyager's terrifying new discovery that shocked the entire space industry, let's explore the remarkable images captured by the spacecraft during its groundbreaking Jovian imaging mission in 1978. Voyager 1 was stationed approximately 265 million kilometers from Earth. From this vantage point, it transmitted a staggering number of photographs back to Earth. In January 1979, it embarked on an extraordinary 100-hour endeavor, capturing a mesmerizing time-lapse movie showcasing 10 rotations of Jupiter. A cornucopia of 3,750 images allowed us to witness Jupiter's majestic dance in vivid detail. In the subsequent months, Voyager 1 ventured through the Jovian moon system, where it made a remarkable discovery: the presence of a diminutive ring encircling Jupiter. Additionally, 2 new moons, the and Medes, were brought to our attention, further expanding our understanding of Jupiter's enthralling realm. To ensure safe passage and prevent a potential collision with Titan, one of Saturn's moons, corrective maneuvers were executed. Voyager 1 continued its celestial voyage around Saturn, uncovering 4 additional moons, Mimas, Enceladus, Tes, Donon, and Rhe. With the completion of the Saturn mission, scientists decided to conclude the Voyager planetary mission, propelling both Voyager 1 and Voyager 2 beyond the confines of our solar system, hurtling through space at an astounding speed of 325 million miles per year. In January 1990, a new chapter commenced: the Voyager interstellar mission. During this phase, Voyager 1 produced some of the most iconic photographs in history, immortalizing the Sun and the majority of the planets. One individual who played a pivotal role in extending the missions beyond their initial objectives was the eminent astronomer Carl Sagan. As a member of the Voyager mission's imaging team, Sean Artley championed the idea of capturing one last set of images, a farewell gift to humanity against all odds. His unwavering determination bore fruit. On February 14, 1990, Voyager 1, positioned 6 billion km from the Sun, embarked on a photographic journey capturing what is widely known as the Solar System Family Portrait. These breathtaking images, totaling 60 in number, added to the spacecraft's impressive collection of 670 photographs. During its encounter with Neptune, Voyager 2 achieved an extraordinary feat. It recorded wind speeds surpassing 1,300 mph, making it the fastest wind ever documented within our solar system. As the spacecraft ventured within 280 miles of Neptune's azure methane-rich atmosphere, it bestowed upon us unprecedented insights into this distant celestial body. Notably, Neptune's largest moon, Triton, was unveiled as one of the coldest locales within our solar system, with surface temperatures plummeting to a bone-chilling 391 degrees. Triton's strange features, such as its nitrogen gas-spewing ice volcanoes that propelled icy particles 5 miles into its tenuous atmosphere, further captivated our imaginations. These extraordinary discoveries expanded our understanding of the immense diversity and intricacy of celestial objects residing in the farthest reaches of our solar system. Don't go anywhere. The Voyager 1 spacecraft has recently made one of its most terrifying discoveries, but first let's see what it has achieved in the last 45 years. The achievements of the Voyager twin probes have been nothing short of extraordinary. More than 4 decades ago, their early observations of Jupiter and Saturn's moons left researchers in awe and shattered previous assumptions about these remote worlds. These moons, once thought to be inactive and heavily pockmarked like our own moon, turned out to be teeming with geological activity. Voyager 2, in particular, achieved several remarkable milestones during its voyage. It made history in 1986 by becoming the first spacecraft to fly by Uranus, and just 3 years later, it accomplished another groundbreaking feat with a flyby of Neptune. To this Day, it remains the sole spacecraft to have embarked on such a path. As the Voyager spacecraft continued its journey, NASA implemented various measures to prolong its operational lifespan over the past 3 years. Non-essential components and heaters have been deactivated to conserve energy, ensuring that these intrepid explorers can continue their mission well into the next decade. Their estimated mission end date is set for 2030 for the scientists and engineers who have been involved in this extraordinary endeavor from the very beginning. The culmination of the Voyager missions is both a moment of pride and a touch of melancholy. Their unwavering dedication and tireless efforts have far exceeded their initial expectations. The wealth of data returned by the Voyagers has provided invaluable insights, fueled numerous scientific discoveries, and sparked the imagination of countless researchers and space enthusiasts. Voyager 1 and Voyager 2 were no ordinary spacecraft. They were meticulously designed as stable platforms with a rotation rate over 15 times slower than the hour hand of a clock. This design choice minimized visual blurring as the spacecraft captured images and data while hurtling through the vastness of space. Even before their encounters with the outer planets, their impressive imaging capabilities began to amaze scientists and the public alike. The spacecraft began transmitting images of Jupiter several months before reaching the gas giant, these early images showcasing the swirl clouds, an iconic great red spot, delighted audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly stole the spotlight. Io, slightly larger than Earth's moon, turned out to be the most volcanically active body in our solar system. The spacecraft's instruments detected peculiar signals from Io, which were confirmed by the vivid images they captured: towering volcanic plumes and a surface scarred by volcanic material. Ejections were unveiled. Peel, one of Io's most prominent volcanoes, has erupted with a force 30 times greater than Mount Everest height, covering an area nearly the size of France. While the spacecraft's cameras were ultimately powered down to conserve power and memory before their journey into interstellar space, it is worth noting that the photos they captured did not include Mercury and Mars for various reasons. In addition to the Voyager 1 and Voyager 2 interstellar probes, NASA has also operated other notable spacecraft such as Pioneer 10, Pioneer 11, and New Horizons. Voyager 1 passed by Pioneer 10 on February 17, 1998, marking the moment when Pioneer 10 became the most distant spacecraft. Voyager 1 continued its solitary voyage for another 14 years before finally entering the interstellar environment on August 25, 2012. Although there were no other space probes in sight to catch up with, NASA did not publicly announce this remarkable achievement until 2013. What are the strategies used that ensured the success of the Voyager missions? In the legendary Voyager missions, one technique stood out as truly brilliant: gravity assist maneuvers. These maneuvers played a crucial role in propelling Voyager 1 and Voyager 2 on their audacious quest to explore the outer reaches of our solar system. To reach these distant destinations and gather invaluable data, the spacecraft needed more than just their own propulsion systems. They needed a boost, and gravity assists provided just that. Imagine the two intrepid spacecraft, Voy 1 and Voyager 2, embarking on their grand tour of the solar system. Instead of relying solely on their engines, they engaged in a celestial dance with some of our solar system's heavyweight planets. This intricate choreography allowed them to utilize the immense gravitational pull of these giants to slingshot themselves on their way. By doing so, they conserve precious fuel and gain the velocity required to visit multiple destinations. Let's delve into the basics of gravity assist, also known as a gravitational swing shot. The idea behind this maneuver is to transfer some of a planet's momentum to the spacecraft as it passes by. Picture Voyager 1 approaching Jupiter, a massive gas giant with a gravitational pull to match with meticulous precision. Voyager 1 swung by Jupiter at just the right angle and speed. Jupiter's gravity tugged at the spacecraft, accelerating it to a higher velocity and providing it with a cosmic boost. Performing a gravity assist maneuver requires extraordinary precision. If Voyager 1 had approached Jupiter at the wrong angle or speed, the slingshot could have resulted in a disastrous deviation from its intended course. The level of accuracy required is mind-boggling. However, the brilliant minds behind these missions successfully executed these gravity assists multiple times, propelling the Voyager spacecraft on a breathtaking journey through the solar system. Voyager 2, for instance, utilized gravity assists from Jupiter and Saturn to Uranus and Neptune. These celestial dances were of pivotal importance in making the grand tour possible. The Voyager missions owe much of their success to these gravity assists. Voyager 1 went on to reach interstellar space, with Voyager 2 quickly following suit, all thanks to the precision of these maneuvers. The concept behind gravity assist is simple, yet the execution is incredibly complex. Voyager 2's grand tour necessitated a level of precision where missing any of these slingshots could have resulted in a failed mission. However, the Dedicated individuals behind these missions were determined and relentless in their pursuit of knowledge, while gravity assists played a key role in navigating the cosmos. Another critical component ensured the success of the Voyager missions, the Deep Space Network (DSN). Think of it as the interstellar telephone line that kept us connected with our intrepid Voyager probes as they ventured into the great unknown. The DSN, although less flashy than a spacecraft, is equally vital. The Deep Space Network is a network of massive radio antennas strategically positioned around the world, including locations in California, Spain, and Australia. These colossal dishes, ranging from 26 to a whopping 70 m in diameter, act as cosmic megaphones facilitating communication with spacecraft traveling beyond our planet. Now, let's explore the role of the DSN and the Voyager missions. The Voyager probes, equipped with cameras, sensors, and instruments, served as our eyes and ears in the vastness of space to make sense of the data they transmitted and to provide them with new instructions. A robust communication system was necessary. That's where the DSN came into play. Imagine this scenario: Voyager 1, on its way to the outer reaches of the solar system, sends a message back to Earth. It's a faint signal traveling at the speed of light. As it traverses the cosmic expanse, the signal weakens. By the time it reaches Earth, it's barely a whisper. However, the colossal antennas of the DSN are poised to capture that whisper. They lock onto Voyager's feeble signal and simplifying it and transforming it into data that scientists can analyze. But the DSN doesn't just receive signals, it also sends commands. The Voyager missions are dynamic endeavors requiring scientists and engineers to adjust plans, redirect the spacecraft, or fine-tune instruments. These commands are sent via the DSN, which transmits them into space to reach Voyager. In essence, it facilitates a two-way conversation between Earth and the farthest human-made objects in the cosmos. One remarkable aspect of the DSN is its relentless operation. It functions tirelessly 247 listening for those distant signals. It's similar to an unblinking eye on the cosmos, ensuring that we stay connected with our spacecraft even when they are billions of miles away. The Voyager missions stand as a testament to the power of collaboration and innovation. While the spacecraft embarked on their incredible journeys, the DSN ensured they were never truly alone. It bridged the gap between our planet and the unknown, enabling us to explore the outer planets and venture into interstellar space. The Deep Space Network is not just a collection of antennas, it is our lifeline to the cosmos. It ensures that the stories of the Voyager missions continue to be written even as the spacecraft journeys beyond our solar system into the uncharted territory of interstellar space. Did Voyager 1 experience a malfunction, or were aliens involved throughout its remarkable 45-year journey in space? The Voyager 1 spacecraft has remained in good health, ently carrying out its mission. However, in recent times, experts have observed some anomalies in its performance that have sparked intrigue and curiosity. Voyager 1 is currently transmitting peculiar signals back to Earth, creating the impression that it is uncertain about its precise location coordinates. What makes this discovery even more perplexing is that the initial data received from Voyager 1 were incoherent and incomprehensible, leaving NASA scientists puzzled. Imagine their astonishment when they realized they were receiving the strange signals from the cosmos. Upon investigation, scientists discovered that the culprit behind the distorted data was the Attitude Articulation and Control System (ACS). This onboard equipment is responsible for measuring, reporting, and adjusting the spacecraft's position in space. It has an antenna directed towards Earth, enabling it to transmit data back home. It was revealed that the ACS had unexpectedly switched to sending its telemetry data through a faulty onboard computer that had been inactive for years. NASA engineers were able to rectify the situation by instructing the ACS to resume sending data through the correct computer. Consequently, uncorrupted data from Voyager 1 are once again reaching NASA. However, the question that remains unanswered is why the ACS switched to the malfunctioning computer in the first place. While NASA scientists have put forth a hypothesis that a faulty command from another onboard computer may have triggered this unusual behavior, they have yet to pinpoint the exact cause. To get to the bottom of this mystery, Suzanne Dodd, the project manager for the interstellar mission, stated that they plan to conduct a thorough memory readout of the ACS and thoroughly analyze its operations. This in-depth analysis aims to diagnose the problem that led to the telemetry issue. It is worth noting that despite the irregular data transmission, the ACS itself seems to be functioning properly, and none of the spacecraft's on-board fault protection systems have been triggered. As a result, Voyager 1 has not been forced into safe mode, and its signal remains strong. One possible factor contributing to this anomaly is the harsh environment of space. Cosmic radiation and extreme temperature fluctuations can pose challenges to the operation of a spacecraft like Voyager 1. Cosmic radiation consists of high-energy particles originating from distant stars and celestial bodies. These particles can penetrate spacecraft structures, causing electrical disturbances, data signal distortions, memory errors, and data corruption. Furthermore, temperatures in the far of space can drop to bone-chilling levels or soar to scorching highs, putting immense stress on the spacecraft's components. Despite the rigorous testing and meticulous engineering that went into designing Voyager 1 to withstand these conditions, the harsh realities of space can still take their toll over time. Another intriguing possibility that has captured the imagination of some is the notion of extraterrestrial interference. Could the unusual behavior of Voyager 1 be attributed to the actions of intelligent beings from beyond our solar system? While this idea may seem more akin to science fiction than reality, it's not entirely outside the realm of possibility. The vastness of space and the countless exoplanets it harbors leave room for speculation about civilizations far more advanced than our own. However, before leaping to conclusions of alien intervention, scientists are diligently investigating every aspect of Voyager 1's anomalous behavior. The meticulous process of analyzing data, conducting tests, and ruling out potential causes is fundamental to the scientific method. While the allure of extraterrestrial contact may be tantalizing, rigorous scrutiny and adherence to empirical evidence remain paramount. In the midst of this investigation, one thing remains certain: the enduring legacy of Voyager 1, regardless of the cause behind its recent anomalies. Voyager 1 stands as a testament to human ingenuity, curiosity, and perseverance. For over 4 decades, it has journeyed through the cosmos, expanding our understanding of the universe and captivating the imaginations of people around the world. Whether Voyager 1's latest mystery is ultimately attributed to a technical glitch, the rigors of space, or something more enigmatic, its story serves as a reminder of the boundless frontier that lies beyond our planet. As we continue to explore and push the boundaries of our knowledge, Voyager 1 remains a shining beacon of humanity's quest for discovery amidst the vast expanse of the cosmos.